Hi, I'm Judy Cole, the Executive Vice President and CEO of the MIT Alumni Association, and I'm delighted to welcome you to this web production of the MIT Alumni Association.
Journalist for Inside Energy of Denver, Colorado. We're a collaborative journalism project that brings energy topics down to earth, supported by the Corporation for Public Broadcasting. So today, this is an interactive forum, so your questions, audience viewers out there, make this whole thing happen. You can submit questions two ways. So the first is on the bottom of your screen, there's a Google form below the live feed. You can put questions there, or you can tweet them with the hashtag MIT Better World, and we'll see those as well. We'll try to get to as many audience questions as we can today. So this month's topic, it's a very hot one, and it's building Hyperloop. Humans in cargo gliding in a tube like air hockey pucks at hundreds of miles an hour. What does the process of taking that from vision to reality entail? Joining us today are alumni with PhDs in 3 different fields: economics, mechanical engineering, and physics, and they'll discuss the possibilities and, of course, challenges ahead for the public and private efforts to build high-speed rail. We're going to talk both about in the US and globally. We've got 2 alumni in faculty roles at schools supporting teams in Elon Musk's Hyperloop competition. You may have heard of this contest because it's one in which the MIT student team has become a force to be reckoned with. And we also have an alum who's at Hyperloop 1, which is one of the private ventures seeking to accomplish some of those goals on its own. So we're going to start with panelist introductions. So panelists, please tell us a little bit about yourself. Give us an overview of your research and your thoughts on where Hyperloop stands today. So we're going to start off with Tyler Susko. Tyler, take us away.
All right, thanks, Jordan. I got my PhD in mechanical engineering at MIT. I studied and specifically researched in rehabilitation robotics, focused on neurological injuries, locomotion, things like stroke and CP disabilities. Worked for Ingersoll Rand before this as a design engineer, did small vehicles, power tools. Now I'm a teaching professor at UC Santa Barbara, right on the beach, and my research is in engineering education right now, and I'm still active with rehabilitation robotics. One of my responsibilities at UCSB is to teach the capstone program, and our largest running project this year has been the Hyperloop project. So just to give an intro to Hyperloop and what it is for everybody that's listening, it was a crazy idea, just as many are, from Elon Musk. I think that it's my understanding he developed the idea. And the basic gist is that there's going to be a pod going through a tube, much like if you picture a bank where you send your package to the teller and it goes up that big tube. Well, we're going to put people in that, and it's going to travel 700 miles per hour. The initial concept was to go to between LA and San Francisco, about 380 miles. And there's some technical challenges here with the tube that's going to be built and with the pod. For the tube, it's 380 miles or something along those lines, and it has to be kept at a low pressure. So you're talking big old vacuum pumps. For the pod, some of the challenges would be a stable bearing surface between the pod and whatever surface it's running over. So if you're thinking about a car, this could be wheels. But at these high speeds, levitation is actually a better option because the wheels might become unstable with any kind of manufacturing defects. Propulsion is different than would be in a car because you have a tube that's launching these pods. It doesn't necessarily have to be inside of the pod, much like a car has an engine. You can do this off board, or you can do kind of a hybrid model and make the pod the rotor of an electric motor, where the stator is built into the tube. Last thing is the considerations for a plunger effect. If you have a tube and you've got something that's going to go shooting through this tube, and you have tight clearances between the tube and the pod, what's going to happen is you're going to build up pressure, even if you partially evacuate the tube in the front, just like you would have if you used a syringe and a plunger. So Elon Musk's initial concept was to put a compressor on the front of his pod that would suck in all the air that was left in that tube and shoot it down for air bearings and maybe a little bit of propulsion, but not much. He was going to use a linearized Tesla model motor as propulsion for this system that would just send it, and then it would levitate. And before getting into our design, just to give you a little bit of a taste of what we've done at UCSB, this is a student project. So I let the students choose everything that went into their project, and I kind of just guide. And our students have chosen, instead of air bearings, to use magnetic levitation. Tesla has set up SpaceX has set up a test track for the students to compete against each other. There's an aluminum floor on this pod. So you can use permanent magnets that are spinning at a high velocity to create some eddy currents and some repulsive magnetic levitation. So that's what we're doing. Our pod's smaller than the ID of the tube, so you can get rid of some of this plunger effect. We have eddy current brakes that are going to brake at high speeds, and then we have friction brakes that are going to brake when the pod becomes at a lower speed. And our pod velocity that we've chosen is 218 miles per hour. It's less than the 700 from the initial concept, but it was the max velocity that you could go in the competition. The whole pod's going to be accelerating with a pusher, so SpaceX is providing a pusher that's just going to give it a shove, and then it's going to levitate from there on. So that's basic gist of what we're doing, and I'll let everybody else give an introduction to what they're doing.
Great, thanks, Tyler. So up next we have Michael Anderson, and he's at UC Berkeley. Michael, take it away.
Thanks, Jordan. So I'm a 2006 PhD in economics from MIT. I think there that counts as like humanities, but you know, we have a good economics program as well as a lot of engineering talent, of course. So I guess sort of my contribution to this forum is maybe sort of as the resident skeptic of the sort of economics of this potential venture. So my own research is in environmental economics, but in particular I've done a bunch of work on both public transportation and also on traffic safety. So I think that the Hyperloop is, you know, a fascinating concept from an engineering perspective and from a physics perspective. But when I sort of first heard about it and you know, started to think about it, the questions that came to mind are sort of what are the problems that we're trying to solve here. And so you can think about, okay, we have two intercity public transportation modes right now, essentially, in, you know, most developed countries. It's aviation is one, and then you also see high-speed rail for sort of the distances that Hyperloop is being proposed for. And so aviation has sort of two problems associated with it. The big one is essentially what you would think of as access and egress time to the airport. The airports usually are located outside of city centers for obvious reasons, and there's also security sort of barriers and so forth that you have to go through also for obvious reasons. The second issue with aviation is fuel burn. It's not that efficient compared to rail or compared to like an intercity bus or something like that. So those are sort of the two problems that you would like to be able to solve with aviation. And then with high-speed rail, there's sort of two different problems. They have the advantage that they can, you know, they can access the city center, and security is not as much of an issue there. Not to say it's impossible to bomb a train, but there's sort of no real benefit to bombing a high-speed train versus a conventional one. And so the main issues that high-speed rail has are, first, the cost of obtaining or building a relatively straight right-of-way, because they cannot, you know, can't take sharp turns at 200 miles an hour. And then also, you can sort of think of the secondary one, at least relative to Hyperloop, being a relatively slow top speed of maybe 200 to 250 miles an hour, 350 kilometers an hour. So when I think about a Hyperloop, I ask myself, does it solve any of these problems? And the answer is sort of yes in both cases, but probably not the more important one. So from the aviation perspective, I think, you know, I mean, I guess you never know until it's built, but I think you would still want security when you're talking about, you know, traveling at 760 miles an hour in an air vacuum in a relatively fragile capsule. You know, I don't think you want bombs on that. And the optimal station location, for sort of reasons I can go into, I think is probably still going to be outside the city center. So you don't sort of solve the access and egress problem. It's not clear yet in the proposals I've seen how you would get intermediate stops, which is sort of another way that you can sort of solve access and egress by, you know, having a stop closer to where people are located. The fuel burn is clearly superior since you're traveling in a near vacuum, but that's actually kind of a second order problem for aviation. So it only costs about $10 per passenger to fly an Airbus 320 from San Francisco to LAX. So the benefit of solving that problem is actually not as big as you would probably think. Then relative to high-speed rail, remember the biggest problem there is you need a straight right-of-way. The Hyperloop actually requires an even straighter right-of-way than high-speed rail because it's going much, much faster, so it requires curves that have even larger radius. And so that problem is not only not solved, it's actually even worse. The top speed, of course, of about, I think 1,200 kilometers an hour, that can sort of save you up to maybe an hour on the typical runs that we're seeing. But sort of using travel or using standard value of time estimates, that's only worth maybe $10 to $15 per passenger, and that's sort of before accounting for the relative discomfort of the mode. So there's sort of the two second-order problems that you could potentially solve, but the first-order problems of either foregoing the need for a straight right-of-way for high-speed rail or having much better access and egress for aviation, neither of those seem, in my opinion, to be solved by the current proposal of Hyperloop.
Great. So a view from somewhat of a skeptic. That's fantastic. So our third panelist, James Dorris, he's with Hyperloop One. So James, take it away.
Hi, thanks everybody. I seem to be having a little bit of a Wi-Fi issue here. See my connections and work with. I am a director here focused on the electric propulsion motor development. We're a private company. We've raised to date a little over $100 million and currently have about 170 people working here, the vast majority of which are engineers and scientists. So I started once upon a time at MIT Course 8 Physics PhD and had some great opportunities there to work in fusion energy research, after which I think I decided I need to work on something where we can make a bigger impact in a much shorter time scale. So I started learning a lot about motors and generators, spent some time at a startup named Fisker Automotive, which maybe people have heard of, and moved over to a computational fluid dynamics company that was in the process of deploying their software in the electric motor industry. And then I came on board with Hyperloop One back in April 2015, so I've been here for maybe coming up on a year and a half. We have thus far had a few local tests, so we test a couple levitation system options here. We have a very unique wind tunnel, which we've built, which allows us to control Mach number, Reynolds number, so that we can test different airfoil shapes in kind of this low-pressure, high-speed regime, which is a bit of a unique regime aerodynamically. And then the test, which everyone has seen, we call it the open air test. It allowed us to demonstrate our first variant of system that was done at our in Las Vegas, Nevada. And if I can screen share a little bit, maybe I'll go ahead and I think in case people haven't seen the video, something like this. Well, okay, let's not wait. So it was basically we were about a 60-meter length of motor. We were able to accelerate the vehicle, which was a small vehicle, about 1,500 pounds, from 0 to 60 in about 1.1 seconds. So it was extremely exciting. We focus a lot on developing the technology, designing the technology, fabricating, delivering, installing, and doing that as fast as humanly possible. We think you can analyze stuff as long as you want, and there's a lot to be said for a really high quality analysis, but there's a ton of unknowns that you'll just miss systems. We focus a ton of our effort and our capital demonstrating our tech, building our test rigs at scale as quickly as possible. And as a company, we're focused at the end of the year. Again, at our Las Vegas facility, we'll be able to demonstrate what we refer to as DevLoop. This is our first development loop. It's not just a propulsion system test. It incorporates the main components of our technology. So that's the propulsion system, that's our levitation system, that's the tubes and the vacuum system for the low pressure. And so all of those things we are in the process of fabricating. Tubes are already on site in Las Vegas. We'll be building this throughout the end of the year and starting testing hopefully before the end of the year. And it's a super exciting time to be here.
Great. Well, thank you to our panelists. I'd like to start off with a question that's for everyone. So in order for Hyperloop to be something that's not a fun sci-fi novelty, but actually something that is viable as we move forward, are we looking at primarily passengers or freight or both or some combination? I'd be interested to hear each of the panelists' perspective on that issue.
So I think it has to be passengers. I don't think that the market for freight that's that fast would be that large.
Unless there's some new item that needs to get there
right.
quickly.
Amazon, whatever, 5-minute delivery, something like that.
Okay.
Yeah, I'd have to agree
So
with. I'd like to hear what James has to say because he's actually trying to make this work.
Yeah, let's hear from James.
Yes, so I'll qualify everything I say with I'm a physicist and I build motors, and a number of these things are definitely a bit out of my specialty area. But I do know some of the things we're engaged in. We actually have agreements in place with at least 3, I think we might be up to 4 entities around which are freight interests, some of which are people interests. The most recent one that was published was the one with FS Links, that a consortium of Nordic, and a number of business interests in both Finland and Sweden. That is primarily a people route, and it'll connect the capitals of Finland and Sweden through an island between the two. I wish I remember what the island name was. And so that there's been a pre-study on that already. And that was performed by PMG and a number of interests in Sweden. So everyone should look that up and read it. I'd be super interested to hear criticism and critique on the numbers. I personally just developed it, so I won't stand by those numbers. We have a number of interests that are actually interested in moving freight as well. One of the concepts is build transportation system for freight. Then at least at some of our levels, we think that that can totally change the idea of inventory. Do you need to actually maintain huge warehouses with huge amounts of goods if you can ship goods from factory to extremely quickly? And so you could have an on-demand delivery system. So there are a couple interests around the world who have reached out to us for the freight question as well. And then another thing that Hyperloop One is doing is something that's called the Hyperloop Global Challenge. We started this in March and it runs through September. So we've basically opened up the question to the world to say, and this is been responded by open state, private equity.
Oh, I think James's audio cut out for a second. So I think Tyler, yeah, thoughts on passengers versus freight?
Yeah, like I said, I mean, what I understood from Elon Musk's original concept, this was supposed to be a passenger thing only. And one of the things I wanted to also talk to Michael about the better access, I think in the initial concept and what I understand of what Elon was proposing would be that these pods would be shooting off every I don't know, a couple minutes to 5 minutes. So in that way, much like when you go to get on an airplane, you have to go there an hour and a half before and all that kind of business, and then you jump on the airplane and the next one's going to fly out in 5 hours. This one would be much like a subway where you'd get on. It would be take you up to I guess we're closer to LA, so it would take me to San Francisco. And the next one, if I miss it, it's just going to be another 5 minutes. That was the idea. So in that way, I do see it as a little bit better access for passengers being able to travel a longer distance. But yeah.
Great. So we do have a question on the passenger issue, and this comes from one of our audience members, Adele in Chicago, who is curious about. So the initial plan is California. So building this system in California, and the question is, where else would be a feasible site for reducing congestion or traffic using Hyperloop, other than California? Where else might this system be a good idea? Or in Michael's case, there may be no places where it's a good idea. But so why don't we start off with Tyler and then Michael on that, and then James if he's back, if his AV is back. Sure.
Yeah. So I think in Elon's initial concept, it was cities that were separated by a distance of somewhere around 300 miles. So something like an LA to San Francisco, and just about anywhere you wanted to put it, you'd put it like that. In terms of travel by air, in Elon's opinion, it makes a lot more sense when you have longer distance. And then travel locally, by a car makes pretty good sense. But something between San Francisco and LA, that 380-mile range, is kind of the sweet spot that he was going for. We've had interest. It was interesting. We got support for our student project, and I gotta say, normally our student projects are $5,000 support. This one has just boomed, $50,000, 10 times the size of the projects. We have 4 times bigger team than we've ever had on this project because there's so much interest. But one of the people that were interested in supporting the project and sponsoring it was the government of Brazil, which was really interesting to us because we were thinking it was going to be just a California thing. And I know James was talking about Finland and Sweden. So I think it's starting to take international press everywhere. It's getting on this.
All right, let's head over to James then in terms of other geographic areas where this could be a good idea.
Sure. So I apologize for the AV difficulty. Again, we've had just incredible interest from entities throughout the world, including Europe again, the Nordic region. We also have some incredible partnerships that have been created. So we have a partnership with AECOM. They build infrastructure with SNCF, that's the French National Rail, and with Deutsche Bahn, that's the German National Rail Company. And so both SNCF and Deutsche Bahn are very interested in our technology and looking at it and seeing what it can do. And then, as I started to talk about, but I think I got cut off, we have what we call the Hyperloop Global Challenge, and it basically allows individuals, companies, state, local governments to submit to us a case that they think locally makes sense for building Hyperloop. And we received over 400 entries so far from 270 from over 72 countries in the world. So news is out there. People are really excited. We've been frankly surprised by the pace of the excitement and the level of interest. We frankly thought that demonstrating our core technology would be required before we got this kind of level of interest. So it's been extremely exciting, and there's definitely no shortage of interest. The real question is what makes sense from the business case, and we're actively working to prove that out with a series of pre-studies. Again, that Finland, Sweden pre-study example, and there will be a lot more of those to come in the coming months.
So I just want to get back to Michael real quick. So Tyler mentioned this 380-mile distance as a sweet spot. What do you think about that? Is there actually a sweet spot for
certainly. Yeah, I mean, there's what economists call sort of comparative advantage of even if the economics don't pencil out, they're still going to pencil out better or at least less worse in some cases than others. And so I agree, definitely you're looking at sort of the same types of distances or city pairs where you would consider high-speed rail, but maybe a little bit longer just because of the higher top speed. So my guess would be something like large cities that are between maybe 200 to maybe 800 miles apart or something like that. I think one of the reasons you don't go longer than that is, at least in the initial proposal, besides maybe just the cost of building such a long thing, is also it's a very spare capsule. It needs to be very small, and so there's no provision, for example, for going to the bathroom. And so once you get above 800 miles, you're sort of asking people to be in there for well over an hour without any access to the bathroom, which starts to become untenable. Just to answer also one of sort of Tyler's earlier points about the vehicle headways. So actually in the original proposal, they're proposed to be even tighter, as tight as 30 seconds. I seriously doubt that you could ever achieve 30-second headways with the sort of safety margins that you require. But even if you could, from an operations perspective, it actually sort of, the problem becomes flipped. So the problem then is not that you miss the capsule and it's like, oh great, I only have to wait 30 seconds for the next one. The problem is you actually have to preload everybody and have long queues of capsules, because you can't just rely on people to board themselves and make that 30-second window that you have before you can leave. And they need to be shooting these out every 30 or 60 seconds in order to actually have a sufficient amount of capacity in the system, because the capsules are so small.
Tyler, did you have a response to that?
No, it totally makes sense. I mean, if we think about how you load a subway, is a little bit easier to get on and off. Yeah, I think you would have to have some kind of a pre-boarding. But I still think it would be a little bit easier than riding that San Francisco to LA flight. I've done it before, and it's you have to get there. And,
Sure.
So next, we did have a question on a kind of a technical debate of air bearings versus maglev for this system. And Tyler, I know you mentioned that your team is using maglev. So let's start off then with James. What's Hyperloop 1 doing?
So we spent a number of hours and months going through this in a very detailed analysis. Of course, we started all of our thinking from Elon's white paper, and so ultimately, and we've actually built both air bearing system to operate in a low pressure system, and we've built a passive magnetic levitation system, which we tested in a low pressure system. Our current plan and our current system, which we're developing for the end of the year, does use a passive magnetic levitation. There's a number of reasons for that. I think one of the absolute critical things is ride height. Most air bearings can only operate in the hundreds of microns in terms of ride height, and how you actually fabricate long sections of track with that kind of tolerance is a real substantial challenge. I should also say we've been involved a bit in the SpaceX design competition. We were in Texas during the initial rounds, and we've sponsored a few of the teams, including the MIT team. And so it's very interesting. A lot of those teams have also elected to go with a passive magnetic system. So I want a lot of analysis on. I think that will be an option.
All right. So Tyler, just curious, what went into your team's decision to go with the maglev system?
Yeah, our students got a little bit scared off by the air bearings for a number of reasons. Trying to scale that up. At the time, we only had $10,000, so trying to scale up to full speed and full size would have been very, very difficult for us to do. The SpaceX competition itself has the rules have almost been crowdsourced as well. So not just the design of the pods, but the size of the tube, the pressure that's in the tube, the type of rail that's going to be running. There's an I-beam to stabilize these things. That was all kind of crowdsourced and changing constantly. So being that was the case, we thought that a system that we could make levitate statically would be much better than something that would be need some speed to start levitating. So I think that's why we went with the maglev. There's also a commercial startup company that's starting to produce these things called ArcPax. They our levitation engines, we developed our own levitation engines to start with, and realized that was a large project in itself. So in order to get the pod going, we purchased 6 of these levitation engines sold by ArcPax. They're a little bit more expensive than we would have liked to pay, but they have some data on them. Actually the technical details aren't fantastic, but But that's why we chose it. A little safer for us.
Great. Another question from our audience on kind of those design decisions. So this one actually comes from Max in New York City. Curious about putting the tube above or below ground. And so if we could hear about this both from a technical standpoint and from an economics perspective. So would any of our panelists like to jump into that one? Above or below ground?
I can. So I think you want to go above. I mean, I think the history of civil engineering is you want to go above ground whenever you can. Tunneling tends to be expensive. So the nice thing from an economic perspective about the Hyperloop, of course, is the tunnel is smaller diameter than a standard road or rail tunnel. So that does save you some money. But tunneling is still it's expensive, and you're always going to have access and egress issues for emergencies and so forth, and maintenance and everything. So I think whenever you can, you want to stay above ground if possible.
Do we have agreement on that from our other panelists?
It's outside of my area, but that sounds like a good argument. The one argument that you have for Hyperloop above ground versus a high-speed rail or any other kind of rail system is the rail system is dangerous. I had another student project this year developing a bumper for trains so that you can reduce deaths. The death toll of trains is actually higher per mile than semis, trucks that are going across country. So per mile, trains kill something like 1.6 times more people. So if you had an enclosed structure that wasn't allowing people to walk on those trails, maybe there would be some societal benefit to that.
Yeah, I think that's a good segue into the question of safety. And, obviously everything will be done to make this system as safe as possible, but kind of the higher speed you get, the kind of the bigger accidents can be. So what can and should be done going forward to make sure we mitigate some of those safety risks? Well, let's go to James for that one, first off.
So of course safety is incredibly important, whether you're transporting freight or people. There are some unique features of Hyperloop that make it kind of a little bit more inherently safe than rail, and I think that Tyler was touching on a few of them. One is the enclosed tube. Of course, you don't have to worry about snow and any damage or weakening any of the friction surfaces. Another is that we build lower tubes to disrupt traffic flows, and so that helps a ton as well. Of course, there's always questions about what to do in an earthquake, and so all of our pylons are being developed on an isolator and damper system, and we're working with experts around the world for early earthquake detection schemes. Ultimately, on the motor side, the whole concept of Hyperloop is that you don't have to build propulsion everywhere along the tube, but we are developing our propulsion system so that not only will we have these large boost stations to, one, to get the vehicle up to speed and then to reboost it, but in between those boost stations there will be a amount of propulsion that's capable to be driven from the vehicle itself, so that the vehicle will always have the ability to get to the next off-ramp, if you will.
Do any of our other panelists want to chime in on the safety question?
So I guess the one thing I would just say is that I think, so the question of whether it could be as safe as aviation or high-speed rail, is in some sense purely an engineering question, and I wouldn't be surprised if it could be. What I would be surprised at is if the original proposed system could be with these sort of 30-second headways, and maybe if you can look at the capsule in the original one, which I understand, is completely, the people who are designing now are doing completely different things, but which is great. But the original capsule was it had these gull-wing doors, which are in some sense almost comical because Elon has made a Model X with gull-wing doors, so you can't even get those to work right. So The idea that you could make something that basically has to like protect against the vacuum of space and has these massive bowling doors that we're sure are always going to seal with 99.99999% reliability doesn't sort of pass the lab test. But the reason it has it again is because the capsules are so small that there's no way to get the people in and out unless you have these massive doors that turn the entire capsule into a door and so forth. So, you know, I think all of these things, all these problems, they can be engineered around, but it's always going to add weight and add diameter, and that ultimately is just going to bring the costs up even higher.
Great. So our next question, this is coming from Celeste in Santa Barbara, and Celeste is curious about opportunities for Hyperloop in the realm of clean transportation and energy. So what will this mean in terms of our energy use, and what will it do, if anything, for transportation's energy consumption?
So I'll start with that. So of course, right, one of the big wins from the Hyperloop system is that our energy consumption, because of the low pressure, we have low drag, and our overall energy consumption is substantially lower than certainly driving or flying. And so there's a net win there. We take the perspective that Hyperloop is energy agnostic, so we will source energy from whatever is locally available. That being said, the propulsion and braking system is entirely electromagnetic. So if you're in a region where there is a lot of energy renewable sources, that is great for powering our Hyperloop system.
Again, I'm curious, Michael, if you could chime in on this from the economic perspective. What would this mean for energy use?
Well, I mean, certainly compared to aviation, it would be, you know, it would be much more efficient, just because, again, you are traveling in that near vacuum. And, you know, I'm an environmental economist, so, like, most people hate it when gas prices get high, but I actually, you know, find some solace in that, because we know that there are all these negative externalities associated with gasoline usage and so forth. But I think especially, you know, just in the last couple of years, we've discovered that oil prices definitely are not going to be getting as high as we thought maybe they were, just because of the hydraulic fracturing technology has gotten so good. So, you know, again, even if you're talking about an airplane flying from San Francisco to Los Angeles, it's only using about $10 worth of fuel. So that's kind of the maximum savings you could get from a pure cost perspective.
Great. So our next question, this is another safety question. This is coming from Pepper in Massachusetts, and the question is: are there any health issues regarding the magnetic flux? Is this going to pose any problems? Say I live right next to the Hyperloop line, or I'm riding on it. Is there going to be any health concerns?
Can jump at someone who builds motors and designs motors. Happy to address that. So the answer is no. Of course, the answer is no, right? So basically, when you design a motor, right? When you design a motor and for the path magnetic levitation, in order to build up enough flux so that you can make use of it for force, you really have to control the flux path and concentrate it very well. So as such, the stray fields that kind of leak out are extremely low. In addition, you are surrounded by a steel great format will get shorted and shunted through the steel tube.
All right, so our next question actually has to do with international competition. So this is coming to us from Bill in San Diego. Curious about specifically Russia and other countries beating us to the Hyperloop. James, is that something your private company is keeping an eye on? Or?
Sure. So there was a news article recently. We are in talks. We have some investment from a Russian investment firm, and there is an agreement in place. We are doing studies with a couple Russian entities. We're doing some studies with a number of people around the world. I'd say that where is the first route going to be built? I mean, again, I build motors. I don't do biz. The biz that going to be built in the U.S. is pretty low. There's a lot of regulatory hurdles in the U.S. We are working a lot with regulatory agencies to try to pull the best and safest regulations from both rail and aviation, and work with regulatory agencies to define a new regulatory for Hyperloop, since we're not really rail and we're not really aviation. And I think the U.S. is going to be a process that's going to take a bunch of time.
Great, thank you. So we have another question on the relationship specifically between Hyperloop and other high-speed rail. So I think maybe Michael would be a good person to start off by answering this. Basically, what's the relationship between the two, and are we going to see competition, coexistence, one win out over the other ultimately? Michael, any thoughts? And this question is coming to us from Jana in Seattle.
Yeah, I mean, I think it's just too early to sort of make any predictions about that. Again, the economics in some sense are very similar, or should really say sort of the political economy is very similar in the sense that you need this very straight right-of-way, and that's just hard to come by in developed areas, which is where you're usually looking to build transportation systems. So if you were just given, perfectly straight piece of land between San Francisco and Los Angeles, it would actually be really cheap to build a high-speed rail system, and who knows, depending on the cost, it might be not that expensive to build a Hyperloop system, but that right-of-way does not exist, and it will never exist as long as California is not falling into the ocean or something like that.
So any other panelists want to jump in on that? Are we good? Okay, so here's a question. If this is going to be something that is primarily passengers and then with some freight, I'm sure it'll be expensive, although we don't have a price point yet. So the question that I'm curious about is this going to be something that's kind of a plaything for the rich? Is this going to be something only wealthy passengers can ride, and is it going to necessarily kind of play into economic disparity? Any thoughts on that from any of our panelists?
I think based on the initial concept that Elon Musk was proposing, he was saying that it's actually going to be cheaper than the high-speed rail. The idea was to build something that would be accessible, quick, to the masses. High-speed rail, he always condemns high-speed rail because of how expensive it is. Even if you think about an Amtrak train that you take, I remember the trips from Boston to Pennsylvania or something, I was spending $70 or $80 a leg, which was more expensive to drive. So the idea was that Hyperloop would be built to be cost-effective, and I would assume that James is thinking the same thing.
Yeah, James, thoughts?
Yeah, I completely agree with Tyler. I mean, we started the engineering of our system. Building a motor is not terribly difficult, but building a motor that exists over really long distances that's very inexpensive is difficult. So everything we do is entirely focused on making sure we have a very strong business case. And if we don't have a strong business case, then people are going to stop investing and no one's going to build it. So I think the only way Hyperloop comes to reality is with a system that can be built at a price point and operated at a price point that is relative to driving high-speed rail and aviation. Michael, do you have any thoughts on this?
I mean, it would have to be, it's public transportation at the end of the day, and it's public transportation that involves a very high fixed cost in terms of building the guideway infrastructure. So the only way you're ever going to be able to make back a return on that is by carrying a lot of people. So there's no way you could ever sort of think of, price it at like $1,000 per ride and just serve a few rich people who are willing to pay that much. It just wouldn't pencil out then.
All right, so we are just about at the end of our time here. So I'd like to finish with sort of a fun question. So I know we don't have crystal balls in our pockets, but if we did, yeah, just give me a year. When will, regular person out there, me, you, when will one of us be able to ride on a Hyperloop? Your best guess. Let's just go around. So let's start with Tyler.
15 years.
All right, James.
I'm gonna get in trouble.
Not trying to get you in trouble.
I think it's entirely possible that we could have a very early version of a Hyperloop operating sometime on or around 2020.
Very soon. All right, and let's see. We didn't hear from Jane. Oh, sorry, Michael. Sorry, Michael.
So I mean, for a demonstration ride, I would have to go with James' estimate because he's the one who's closest to building it in terms of sort of a commercial service where you would expect to hop on it, just like you might hop on a train or on a flight to LA. I don't know, decades or maybe never. Who knows? Just depends.
All right, good range of answers there. So yeah, any final thoughts from any of our panelists? Any burning things that you really want to get out there? All right.
I guess I can conclude this talk by saying that, I think that this has become so exciting to everybody because of the fact it's a new mode of transportation. It's kind of like your Wright brothers moment here, and that's why the kids are getting so excited about it, the students. There were 1,200 applications in the SpaceX competition, and the news has been covering this like nuts. Our students have had such great opportunities because of this competition and this movement. So I think it's exciting. I think it's going to happen. I don't know when it's going to be feasible where we'll actually just be jumping on this Hyperloop to take us up to San Francisco, but I'm pretty sure it's going to happen.
All right, any other of our panelists? Closing thoughts? All right, well, this has been wonderful and enlightening. So on behalf of the Alumni Association, I would like to thank you all for tuning in to this faculty forum online. A special thanks to our MIT alumni panelists from UCSB, Cal Berkeley, and Hyperloop One. And thank you to our audience for all of the great questions. We tried to get to as many as we can, but did not quite get to them all. But we will be sharing those questions with our panelists who will then have a chance to respond via email. So thank you again for your questions. And please, if you do tweet about today's chat, use the hashtag MIT Better World, and you can also send follow-up questions or any feedback about this panel at all to alumnilearn@mit.edu. So thanks for watching, everyone. Have a great afternoon.
Thanks again for joining us. For more information on future MIT Alumni Association productions, please visit our website.